maybe, and now we can briefly go through step by step.
Markus, what is a turbo compressor?
Actually, for that matter, I brought a slide with me, or an image that I could show you to give you a little bit of an overview how such a turbo compressor looks like and how it functions.
Okay, yes, we see it.
So you can see it. All right, great. So on the left-hand side, you can see a simplified schematic overview of how such a turbo compressor is built. So fundamentally, it consists of three, or in the simple form, it consists of three parts, which is the impeller, so the wheel that works on the fluid.
Yes.
The diffuser, which is followed by our impeller, and after the diffuser, we have a so-called volute or spiral casing, which connects the compressor to the fuel cell stack, for instance.
So the impeller is that number 2 on that picture, number 2, and that's what spins.
So impeller is you can see it right here.
Yes.
Diffuser is number 4, and the spiral casing is essentially number 6.
Understood. Understood.
Exactly. So maybe, and now we can briefly go through step by step.
Yes.
What happens, like from a fluid perspective. So at inlet, which is indicated by number 1. Going essentially the flow is directed towards the eye of the impeller. One's talking about the eye, which is the center of this impeller. The high rotational speed. Impeller is rotating. We have a so-called flow passage, which is generated by the blades of such an impeller.
Yep.
Where we have essentially an increase or a change in angular momentum of the flow, and a change of total pressure. So across this flow passage, which is created by the spiral casing, which is the outer contour, and the impeller, around 60% of the total pressure increase is taking place.
Okay, so as that spins, that increases the pressure going out. Okay.
Correct. Correct. So it's essentially, first of all, it changes the angular momentum and it increases the total pressure. Okay. What is interesting to note, after, for instance, at the edge of this impeller, we have still flow velocities of around 200 meters a second, which means we need to still decelerate this flow to further increase the static pressure that is required for certain applications. This is done by the so-called diffuser, where we increase the volume, thereby increasing the static pressure. After the diffuser, we have, as I said, the so-called spiral casing or the volute, where we further reduce the radial velocity and collect the flow towards the end application, which could, for instance, be a fuel cell stack.
Yeah.
And maybe on the right-hand side, you can see one of our more recent designs that we have already presented at numerous fairs, where we can see actually how it looks in real life, which is a cut through of one of our CAD designs. So maybe I can also show you how typically what is the variation of such impeller designs, which is, from my perspective, very interesting to see. As you can see, there's a huge variety. So-called mixed flow designs, where we have also a radial component, or the classical design, which one would see in fuel cell stack application.